All right, let's get you ready for that Unity exam. Today, we're zeroing in on a topic that is absolutely essential, not just for the test, but for pretty much everything you'll ever do in Unity. We're talking about the transform hierarchy and space conversion. So let's jump right in.
So, how do you do this stuff? I mean, these are real-deal game development problems, right? This isn't just some abstract theory. This is the nuts and bolts of equipping items, building a radar, spawning particle effects. It all comes down to the core concepts we're about to nail down, and you can bet the exam is going to hit these hard. So here's our game plan for this study session. First, we're going to become digital puppeteers, figuring out how to link objects together. Then we'll dive into what I like to call GPS versus dashboard coordinates. Trust me, it makes sense. After that, we'll cover a really common exam trap involving scale, and finally, we'll hit the exam blitz to make sure all this knowledge is locked in.
Okay, let's start with parenting. The best way to think about this is like a marionette puppet. You move the main wooden crossbar at the top and all the strings pull the arms and legs along with it. In Unity, that's a parent-child relationship. The parent's position, rotation, and scale all affect the children. Getting a handle on this is step one. The number one tool you're going to use for this is transform.setParent. It's how you make those connections on the fly, right in your code. But, and listen up, because I practically guarantee this is on the exam, the real magic, the part you have to understand, is that second argument. It's just a simple true or false, but it completely changes what happens. So here's the deal with that critical Boolean, WorldPositionStays. If you set it to true, and that's the default by the way, the object doesn't move. Visually, it stays exactly where it is in the world, and Unity does a bunch of math behind the scenes to make that happen. But if you set it to false, it's like a magnet. The object just throws away its world position and snaps right to its new parent.
And this right here is the perfect example of why you'd use false. Let's say you model a gun, and you make sure its handle is right at its local origin, at position 000. Then, in your code, when the player picks it up, you just call setParent, point it to the player's hand, and pass in false. Snap! The gun's 000 instantly aligns with the hand's 000. It's equipped perfectly. No extra math, no headaches.
Okay, great. So our objects are all connected. The gun's attached to the hand's attached to the arm. We've built our puppet. But now, what if a script on the main player object needs to find that hand or a finger? How do we actually navigate through these connections we've just made? Well, you basically got two main options. First is transform.find. Think of this as a search function. You can give it a full path, like body/arm/hand, and it'll dig down through the hierarchy to find it. It's powerful, but it's slow. You really want to avoid using this every single frame in an update loop. On the other hand, you've got transform.getChild. This one is lightning fast. It just grabs a child based on its order, its index number. Perfect for when you need to just loop through all the children and do something to them.
All right, let's switch gears and talk about coordinate spaces. Now, this can sound a bit mathy and intimidating, but the analogy makes it super easy. Just think of world space as a global GPS coordinate. It's an absolute, fixed position on the map. Local space, on the other hand, is like directions from inside your car, 2 meters straight ahead, or turn left. It's all relative to where you are and which way you're facing.
So here's a classic problem. Your code says, I want to spawn a bomb 2 meters in front of my player. See, in front of is a local dashboard direction, but Unity's function to create objects needs a world GPS coordinate. So how do we translate one to the other? That's where TransformPoint comes in. You give it your local direction, like 002, and it spits out the exact world position you need to spawn that bomb.
Now let's flip it around. You know an enemy's world GPS coordinate. They're over there. But what your game needs to know is, from my player's perspective, are they in front of me or behind me? To my left or right? For this, you use InverseTransformPoint. It takes that world position and translates it into your local dashboard space. Then you can just check the z-value. If it's positive, they're in front. Negative, they're behind. It's that easy.
All right, one last major concept before we hit the quiz. This is a quick one, but it's a huge gotcha on the exam because it's a little counterintuitive at first. Let's talk about scale.
So you have two different scale properties to worry about, LocalScale and LossyScale. LocalScale is the one you can actually change, the one you see in the inspector. It's the object scale relative to its parent, but LossyScale, that's the object's final, actual size in the game world, after its parent scale and its grandparent scale have all been multiplied together. The key takeaway here is that LossyScale is a result. It's a calculated value, which means it is read-only. This is it.
This is the exam tip. Just burn this sentence into your memory. If you see a multiple-choice question with a line of code that tries to do something like transform.LossyScale equals new vector 3222, you know instantly that's the wrong answer. It will cause a compiler error. You cannot directly set the world scale of an object.
Okay, theory time is over. Let's put what we've learned to the test with some questions that are straight out of the exam playbook. This is how you really make sure the concepts stick. You ready? First one up. You've got a sword, its handle is right at its local origin, and you need to snap it into the player's hand perfectly. Which one of these lines of code is going to do the job cleanly? Take a look.
And the correct answer is C, using SetParent and passing in false.
So why does this work? Because passing in false tells Unity, hey, forget about where this sword is in the world right now, just keep its local position of 0, 0, 0 and apply that to the new parent, the hand. That's what gives you that perfect snap. If you'd used true, the sword would have just stayed on the floor, which is definitely not what we want.
Question 2. Time to build that radar system. You've got an enemy's world position, and you need to figure out if they're on the player's left or right side. Which one of these tools is specifically designed for that job?
That's right, the answer is B, InverseTransformPoint.
This is that perfect GPS to dashboard conversion we talked about. You take the enemy's world coordinate, you run it through InverseTransformPoint on the player, and it gives you back a local coordinate. From there, you just check the X value. If X is negative, they're to the left. If X is positive, they're to the right. Simple as that.
Okay, last question. Check out this hierarchy. You've got a script on the main player object, and you need to get a reference to the hand, which is buried way down deep. Which of these options is going to work?
The correct answer is B, using transform.find with the full path. Option A wouldn't work because hand isn't a direct child of player. And getChild in option C also only looks at direct children. Only find lets you search deep into the hierarchy using that path string. And there you have it. You now have the fundamental tools to manage complex object relationships and to translate between different coordinate spaces. This is the stuff that lets you build amazing equipment systems, smart AI, dynamic UIs, you name it. So the only question left is, now that you know how, what are you going to build first? Good luck on that exam. You've totally got this.